Hello everyone, my name is K. Rajesh. I am from CSC section. Today's my topic is about demonstrate unrolled linked list. Introduction. An unrolled linked list is a linear data structure that is a variant on the linked list. Instead of just storing one element at each node, unrolled linked list store an entire array at each node. It is also known as cache sensitive data structure. The term cache has been taken from the cache memory, which is associated with CPU. A cache memory is used to store recently visited pages or data so that they can be made available for RAM immediately without accessing secondary or permanent memory. Unrolled linked list. A linear data structure called an unrolled linked list is a variant on the linked list. Unrolled linked list store a full array at each node instead of simply one element at each node. Unrolled linked list combine the advantages of an array, low memory overhead, with the advantages of the linked list, rapid insertion and deletion to, to achieve dramatically improved performance. Unrolled linked list effectively spread out the overhead of the linked list across several items by sorting numerous elements at each node. So if each node of the unrolled linked list holds an array of four elements, the linked list overhead, that is pointer, is distributed across those four elements. When you examine the cache management of contemporary CPUs, unrolled linked list performs better. When compared to a standard singly linked list, unrolled linked list have a somewhat significant overhead per node. However, in most cases, this disadvantages is minor in comparison to the benefits of the modern computers. The unrolled linked list is a linked list in which each node carries an array of various rather than just one. Each node's array can contain anything that are conventional array can, including primitive kinds of and other abstract data types. Each node can carry a maximum amount of values, and most implementations keep each node at above 3 by 4 capacity. When specific arrays becomes overflowing, it does it does so by transferring values between them. The unrolled linked list has the somewhat higher pre-node overhead since each node has to store the maximum number of values its array can carry. However, as compared to the standard linked list, it has a far cheaper per value cost. The average storage space required per value decreases as the maximum size of the array in each node grows, and the space advantages are considerably bigger when the kind of the value is very small. The unrolled linked list is a hybrid of the array and a linked list. It takes advantages of arrays, ultra fast indexing, and storage locality. The underlying features of the static array provides both of these advantages. Furthermore, it retains the linked list advantages of node insertion and deletion. Each node in the unrolled array contains a certain maximum number of elements. The number of elements are large enough to fill a single cache line. The position of the element in the list can be indicated either by reference or by position in the array. An unrolled linked list can be shown like following. Need of unrolled linked list. One of the biggest advantage of a linked list over array is that inserting an element at any location, taking only big O of 1. However, the catch here is that to search the element in the linked list takes big O of n. So to solve the problem of searching that is reducing the time for searching the element, and concept of unrolled linked list was put forward. The unrolled linked list covers the advantages of both array and linked list, as it reduces the memory overhead in comparison to simple linked list by sorting multiple elements at each node. And it also has the advantages of fast insertion and deletion as that of the linked list. Implementation of unrolled linked list. Each node, each node in the unrolled linked list contains three types of information. An array consisting of various array length and a pointer to the next node. Each array is a node in a node can hold a certain number of elements. Let us let us call it a capacity. However, typically it is not filled to its maximum capacity. Generally, the length of each array is in the node is equal to the minimum threshold. Moreover, the unrolled linked list has two pointers, head and tail. Head head points to the first node and tail refers to the last node. The operations those can be performed by the unrolled linked list are insertion and deletion. Insertion. An unrolled linked list is a linked list of small arrays, all the same size, where each is so small, and insertion or deletion is fast and quick, but large enough to fill the catchy line. An interior pointing into the list consists of both the pointer to a node and an index into node containing an array. It is also the data structure and is another variant of linked list. It is related to B tree. It can store an array of elements uh, at a node, unlike the normal linked list, which stores a single element of the node. It is combination of array and linked list fusioned into one. It increases cache performance and decreases the memory overhead associated with sorting reference for metadata. First of all, it is checked if the space is available in the list for inserting a new element. If the space is available, the element is just inserted. When the element is inserted in the array elements, the count variable is incremented by 1. If array doesn't have free space to have an element, we just create a new node, place it after the current node, and move half of the elements to nearly created node. It creates room or space for the new element. If the list is empty, that is head is equal to null, then the value is to be inserted in the first value. We create a node and add the given value to the nodes array. The array length gets increased by 1. Both the head and the tail points to this node. If the list is not empty, we check if the current node's array can be fit in a new node. If it can, we append the given value to the current node's array and increase it by 1. Otherwise, we create a new node. We move half of the element from the current node to the new node, such that the length of the current node is equal to the minimum threshold. We add the given value to the new node and set its length. We also need to update the current node's length. Moreover, we set the current node's next pointer to refer the new node, and also update the tail to point to the new node. Deletion. When the element is deleted from the list, it is simply removed from the array. If the number of elements in the array falls below n by 2, we take the element from the neighboring arrays to fill the array. If neighboring arrays also has n by 2 element, then we merge both of the arrays. The operation of the deletion is the opposite of insertion. First, we find the first appearance of the given value and remove it from the array. After the removal, if the current node's length is less than 50% of the maximum capacity, We move the element from the next node to the current node till the condition is not satisfied. We also check if the next node's length is less than 50% of the maximum capacity. If it is, then we merge the current node and the next node. If the value does not exist in the list, then we throw an error. Traversal. Here we traverse through the unrolled linked list. We start at the head and move node by node. Each each node, we iterate over the array and print its items. Advantages of unrolled linked list. Due to its catchy behavior, the unrolled linked list performs a sequential traversal very rapidly. It, it requires a less storage space. It performs the operations more quickly than the ordinary linked list. Indexing time big O of n is reduced to big O of n by max, as we are able to process the whole load at a time instead of individual elements. Disadvantages of unrolled linked list. The overhead per node for a reference and elements count is considerably high. Element example, let's say let's say we are having 8 elements, so square root of 15 is equal to 2.82, which rounds off to the 3. So each block will store 3 elements. Hence, to store 8 elements, 3 blocks will be created, out of which the first two blocks will store 3 elements, and the last block would store 2 elements. Thank you.